Hi there, this is a geometry video. It is chapter 7, section 3, and today we will be discussing similar triangles. Alrighty, so we have basically three theorems slash postulates, one postulate and two theorems actually. And they are very similar to how we did congruent triangles a few sections back, which is, if you remember, side, angle, side, 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 angle, angle, side, and that kind of thing. They're very similar to that. Basically, it's how did I just say that twice? Anyway, it's going to reduce the amount of work that we've had to do from the previous lesson. We saw in the previous lesson, 7.2, that in order to prove that triangles and or polygons were similar, you had to show that all of the sides were proportional and all of the angles were congruent. So that can be a lot of work. And so what we want to do with this section is to kind of reduce that amount of work. So in this case, we have our first postulate, which is the angle-angle similarity. So that's what it's called, angle-angle similarity. And it says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So in other words, like in this example, if angle A is congruent to angle F, because they have one arc there, and angle B with two arcs is congruent to angle G with two arcs, then triangle ABC is similar to triangle FGH. So that means that we don't have to go and check all of the proportional sides or anything. We can just base it off of those two things. If two pairs of angles from one triangle are congruent to two angles of another triangle, then basically the triangles are similar. So we have our first example, and here it is. It says, determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So here we can see that angle L is congruent to angle M. They're both 57 degrees. But then for the second angle, we have a 48 and a 75. So we have to do a little bit of work there before we can actually make sure that they're the same. So we know that in each triangle, they need to add up to 180. So if I take the 180 and subtract the 57, and subtract the 48, I get 75. And we know that angle P is 75. So we don't have to calculate angle Q, even though we know that it's 48 degrees, because we now have two pairs of angles that are congruent. Angle L is congruent to angle M. So as far as explaining your reasoning, we're going to say that angle L is congruent to angle M. And we also know now that angle K is congruent to angle P. And after that it says, so in this case, because we found two pairs of angles that are congruent in each triangle, then we know that the triangles are in fact similar. And if it is, they want us to write a similarity statement. A lot of times students forget to do that and they get the problem wrong. So please don't forget to do that. So remember that when you write out the triangles, you have to put the letters in the right corresponding order. So it doesn't really matter what you call the first triangle. So I'm going to say triangle JKL is similar to triangle, and then I have to make sure that the letters are in the right corresponding order. So we know that L corresponds to M and that K corresponds to P, which means that J must correspond to Q. So Q is going to go there. K, which is the second letter, corresponds to P, so we're going to put P here. And then L, which is the last letter, corresponds to M, so we're going to put the M right here. So there's my similarity statement. And as far as explaining my reasoning, I already did with this portion here. So now we're going to go to part B. And in part B, we have a little bit, we don't have any of the angle measures given to us, but we do know that vertical angles are always congruent, so we can automatically mark this angle congruent to that angle. And then we have also that they're parallel. And if you remember back in the day, we learned that when you have parallel lines cut by a transversal, whether you call this the transversal or that the transversal, either way, we have alternate interior angles congruent. So that means that angle X is congruent to angle T. Alrighty, and furthermore, we also know that instead of doing X, you could also do angle R congruent to angle W. But either way, you have at least two pairs of angles that are congruent. And so by the angle-angle similarity theorem, then the two triangles are in fact similar. So to write our similarity statement, we're going to put triangle, again, it doesn't matter what you call the first one, I can call it RSX, RSX, but the second one has to be in corresponding order. So since R corresponds with W, we're going to put W first, and then S is in the middle, and T. So RSX is similar to triangle WST. And so then if you'll do it yourself and go on the bottom here, then we will move on to the other two theorems, which are side-side-side similarity and side-angle-side similarity. Now recall that when you were trying to prove triangles congruent, you wanted the three sides to be congruent. In the side-angle-side case, you wanted two sides congruent and the angle in the middle of the two sides to be congruent. But this time, we don't want side lengths to be congruent anymore. We want them to be proportional. So it's a little bit different when you're talking about similarity. So it says here, if the corresponding side lengths of two triangles are proportional, in other words, all three pairs of sides are proportional, then the triangles are similar. All right, so basically over here, so that for those of us that want to look at a diagram that makes it more clear for us, it's all color-coded. So basically we're saying that the red segments, which are corresponding, so JK to MP, that ratio is the same as the ratio of KL to PQ, which are the blue segments. And then the green segments are LJ and QM. If those three ratios are all the same, then triangle JKL would be similar to MPQ. That's side-side-side similarity. In the side-angle-side similarity case, it's a little bit different. We have only two pairs of sides that are proportional, but again, the angle has to be in between those two sides that are proportional. Again, it's all color-coded. So it says if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So we have here in a more concrete format, if RS is if the ratio of RS to XY, which is the red segments, is the same as the ratio of ST to YZ, which is the blue segments, so you can see here those two segments there. And furthermore, you have to have the angle in between the two sides, so angle S and angle Y have to be congruent. If those two things happen, then triangle RST is similar to triangle, oops, wrong symbol there, we don't want congruent. Then triangle RST is similar to triangle XYZ. And so we're going to do some examples to try to apply some of that here. Alrighty then. So here we go with example 2. And it says, determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. So we have here, none of the angles are marked congruent, but again, like I said before, we know that anytime you have vertical angles, they are congruent. Alrighty, so if you are going to claim that these triangles are congruent, then they have to have the same ratio of the sides. So we're going to go with 5 is to 12.5. And then we're going to do 8 is to 20. And then we're going to do 6 is to 15. If these ratios are all the same, then we don't have to worry about angle measures. Even though these are vertical angles, we need two pairs of congruent angles and we only have one pair, so that wouldn't work. We couldn't use angle-angle similarity. We might be able to use side-angle-side, or we could use side-side-side. But in this case, since they gave me all three side lengths, I'm going to go ahead and try side-side-side. So 5 is to 12.5. That's going to give me 0.4. 8 to 20 is going to also give me 0.4. And 6 to 15 is also 0.4. So in this case, all of the ratios of the corresponding sides have the same ratio, 0.4. And therefore, based on the side-side-side similarity, we have that the two triangles are similar. So what we want to do now is to make sure that we write our similarity statement. And so we're going to go triangle PQR. And again, we want to make sure that we have them in the right order. So PQ is going to correspond with ST. So it's going to be STR, like that. They have to be in the right order. Remember that, because if you don't put them in the right order, then we're going to have some problemos. So PQR is similar to STR, and I think that's it. They don't actually ask us for the scale factor, but the scale factor is 0.4 if they had asked for it. All right, so then we're going to go on to part B. And in part B, I think I might have, nope, I thought maybe I had missed something on the diagram as far as parallel, but I have not. But we're going to do something else here. And what we see here is I think that we can try to use side angle side similarity. And I'm going to leave it as a question mark right now because it's just what I'm thinking when I look at the diagram. And so what I see is that there is basically two triangles. There is the triangle AEF, and then there's triangle ACB. And the triangle AEF is like on top of ACB, which means that they're sharing angle A. Both triangles are sharing this angle here, which means that angle A is congruent to itself by the reflexive property. So we have the angle that's in the middle of the two sides, and my two sides are here. Okay, so what I have to do now is check that those two sides have the same ratio. So in the smaller triangle, the ratio is 8 to 10. Or I should say 8 question mark 10. Okay, so this side is 8 and this side is 10. So now what I want is this side. In other words, the big triangle is 8 plus 4. So that's 12. So I'm going to say 8 is to 12 as 10 is to 10 plus 5, which is 15. Now, as long as these have the same ratio, then we're good to go. And so 4 goes into 8 2 times, and 4 goes into 12 3 times, so we get a ratio of 2/3. And over here, 5 goes into 10 2 times, and 5 goes into 15 3 times, so again we get 2/3. And since they have the same ratio, then we can say now for sure that by the side angle side similarity, these two triangles are similar. So we want to write the similarity statement. So we're going to say triangle AEF is similar to triangle ACB. All right? Don't forget to write your similarity statements. A lot of times people forget to do that and then they get the answer wrong. All righty? So there we go for part B. And then we're going to let you do this little guy. Same directions. Basically determine whether the triangles are similar. If they are, write the similarity statement and explain your reasoning, which basically means to tell me which theorem that you're using or postulate. All right, example 4. And no, I'm fully aware that I skipped example 3. I just wanted to stay consistent with the numbering in the book. So rather than call this example 3 and then have you confused if you're looking at the book, I went ahead and I did skip example 3 from the textbook. And so now we're going to go on to example 4, where we're going to be using our theorems to help us find missing links. Alrighty? So before we can do that, we have to determine that the triangles are actually similar. So our first step is to determine whether or not the triangles are similar, and then we can go from there. So this is a lot like the one that we just did earlier, where you can see, let's see here. This time we actually know that these are parallel. So we can determine by angle-angle similarity that the two triangles, so again we see a small triangle here, ABE, this small triangle, and the big triangle ACD, okay? And so when we look at the two triangles, they are sharing angle A. So angle A is congruent to angle A, That's one pair of angles congruent between the two triangles. And then, because these are parallel, we know that corresponding angles are congruent. So we had that one. Now we have that this angle is congruent to that angle because they're corresponding angles with these two parallel lines. And for that matter, so are these angles here. So either way you go, you're going to find that there's at least two pairs of congruent angles. So these two triangles are similar. Now that's important. So we know that a triangle ABE is similar to ACD by the angle-angle similarity. Okay? That's important because once we know that the triangles are similar, then we can apply the fact that their corresponding sides have to be proportional, and that's how we're going to figure out what this variable is here. Okay, so we know that y, which is this smaller side, y is to the entire side. Okay, so if this portion is y, then the entire side must be y plus 3. Okay, which is what that says there. And then we go to the other side and we have 3, which is the smaller portion here, compared to the entire length, which is 5. So we get this proportion here. And then we can solve it. So 5 times y is 5y. And again, remember that when you have a binomial with two terms, you want to make sure that you use parentheses so as to not forget to distribute. So 5y equals 3y. 3 times y is 3y. 3 times 3 is 9. And then we want to combine our like terms. So we move the 3y's to the other side. 5y minus 3y gives us 2y equals 9. And then lastly, we divide 9 by 2, and we get that y equals 9 halves, or basically 4.5. Alrighty? And that's all they wanted us to do in, online. They didn't want us to just find y. It says to find BE. So BE is this segment here, and CD is 3.5, okay? So we know that y is 4.5, so this is now 4.5. And AD, where's AD? So to find AD, that's going to be simple because it's basically y plus 3. So 4.5 plus 3 is 7.5. So AD equals 7.5. And then to find BE, we're going to have to use a proportion. So we can say, let's see, 3, where do I want to write that? I'm going to do that in a different color. So to find BE, we're going to have to call BE X. We don't know what that is. So we're just going to use a regular proportion. So I'm going to say 3 is to 5. So this short side is to the long side, as X is to this side, which is 3.5. We're going to solve that guy. 5x equals 3.5 times 3. Where's my calculator? 3.5 times 3 is going to give you 10.5. And that divided by 5 is 2.1. So x is 2.1, which means BE is 2.1. BE equals 2.1. So AD equals 7.5, and BE equals 2.1. So those are our two answers right there. And so now we're going to have you try something similar with these two diagrams. And then we're going to go to our last example, which is using indirect measurement. So it says, Hallie or Haley, I'm not exactly sure how you're supposed to pronounce that. Holly, I don't know. But that person is estimating the height of the Superman roller coaster in Mitchellville, Maryland. She is 5 feet 3 inches tall, and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? So I've created a diagram here that's kind of depicting the scenario. So we've got the actual roller coaster, which is this entire side here, is what we don't know. We don't know how tall that roller coaster is, so we're going to call that length x. But we know that the shadow of that roller coaster is 40 feet. And then we have her shadow is 3 feet. So she's inside here. They're sharing the same triangle here. So she's 3 feet of a shadow. But her height is 5 feet 3 inches. So that's where the problem comes, because you can't have feet and inches in the same problem. So the first thing we have to do is actually convert her height to all feet. So we know that it's 5 feet plus 3 inches. So we need to know how much 3 inches is in terms of feet. So that's a conversion factor problem. We know that there are 12 inches in a foot. So we're going to go 12 inches to 1 foot. So basically we're going to get the inches to cancel. And 3 divided by 12 is basically 1/4 feet. So basically she's 5 1/4 feet. All right, so 1/4 feet is basically 5.25. So you'll notice that in my diagram, her height right here is 5.25 compared to the height of the roller coaster, which is x. Okay, now because these are similar triangles, they have a shared side here, and these are parallel because the angle of the sun is going to cause it to happen. So you have a scenario, and so now what we want to do is just figure out the missing length. And so we're going to say 5.25, which is her height, compared to the height of the roller coaster. And then we're going to put 3 feet, which is her shadow, compared to the shadow of the roller coaster, which is 40. And then we're just going to solve this proportion. 3x equals 40 times 5.25, which is 210. And then we're going to divide that by 3. And we get 70. X equals 70. Therefore, we know that the roller coaster is actually 70 feet tall. And that is how we use indirect measurement and proportions together to get the missing length. So now we want you to try this guy, this little example here. And once you've completed this example, you will have completed your notes for this lesson. And I will see you in class. And thank you for watching.